Problem 231. A rock is dropped from a treetop 19.6 meters high. 1 second later, a second rock is thrown down. With what initial velocity must the second rock be thrown if it is to reach the ground at the same time as the first? Let's begin by drawing a coordinate system with a y-axis starting from the ground. So y equals 0 at the ground. And rock number 1 now at time 0 is 19.6 meters above the ground. 19.6 meters. So for a kinematic equation for rock number 1, we can write that its position above the ground, its height above the ground, is h naught minus 1/2 gt squared. And I'm interested in solving for t when the position is 0, and in other words, in finding out how long it takes rock number 1 to hit the ground. So if I solve this equation for t equals 2 h naught over g square root, which is equal to 2 times 19.6 meters divided by 9.8 meters per second squared. Meters divided by meters per second squared is second squared. Square root of second squared is seconds, as appropriate for the time over here. So 9.8 goes into 19.6 twice. 2 times 2 is 4. Square root of 4 is 2. So the time for rock 2 to fall to the bottom, to the ground, is 2 seconds. For rock number 1 to fall to the ground is 2 seconds. And for rock number 2, it is thrown 1 second later. So it has to reach the ground in 1 second after it's thrown. And so let me write a similar equation for rock number 2. Its position is equal to its initial height minus Vy naught t. This is the initial velocity we're going to be solving for. A minus because rock number 2 is thrown downwards at that velocity, minus 1/2 gt squared equals 0. So I know what the height is. I know that time has to equal to 1 second for it to fall at the same hit the ground at the same time as rock number 1, and I know what g is, of course. So really the only unknown here is Vy naught. So I can then solve for Vy naught. I'll do that in 2 steps here. Vy naught t is equal to h naught minus 1/2 gt squared. And Vy naught is then equal to h naught over t minus 1/2 gt. And that's going to be equal to 19.6 meters divided by 1 second minus 1/2 times g, 9.8 meters per second squared, times 1 second. So this is 19.6 meters per second. That's the first term. Second term is 4.9 meters per second. 19.6 meters per second minus 4.9 meters per second is 14.7 meters per second.